This will be my attempt to review homework number 4, negative exponents. I will get as far as I can. So first of all, we want to make sure we simplify the following monomials, and the answer should always contain positive exponents. So we're going to have to play around with where we put the variables and the exponents. So if I see x to the negative 7th power, I'm going to rewrite that like this. So I'm just putting, basically flipping it, the reciprocal of 1 over x to the positive 7th. Over here, I have negative 4, a to the negative 2nd, b to the negative 2nd. So, sorry, number 2 is 5x squared, y to the negative 3rd. So I'm going to hold on to any positives above, and I'm going to use the reciprocal downstairs. Number 3, I'm going to have negative 4. I'm going to hold on to that coefficient, because that's fine to have a coefficient of negative 4 on the top. But then there's actually nothing else up there, because the other 2 I'm going to bring downstairs for number 4. So I'm going to write this out as a, I'm using a couple different rules here, to the negative 4, and then b to the negative 8, the product rule. And then I'm going to bring those downstairs. So you always are going to keep 1 upstairs as the numerator, and then b to the 8th. Number 5, negative 8. And then I have x, 3 times 5 is 15. I've got negative times negative. And then I have y to the negative 20. And then I could rewrite that equal to negative 8x. To the 15th, so keep that upstairs, and then I'm going to bring that negative down here, y to the 20th. I'm going to put that in a box because it's starting to get a little messy here. Okay, now I'm going to think of this like 3x. Well, first of all, I'm going to have negative 3x, and then I'm going to have 1 over 27. And the answer, if I put it in the correct form, is going to be 1 over 27 x to the positive 3. Over here for number 7, I'm going to use my exponent rule. I'm going to add those 2 exponents, negative 5, and I'm going to end up with 1 over a to the positive 5. For 5th power. Here I'm going to x to the negative 9, and then on the over here on this side I have 16 y to the 20th. So again, I'm taking 2 and I'm raising it to the 4th power, and then y I'm raising it to the 20th because of 5 times 4. I'm going to rewrite this now though as 16 y to the 20th, because remember that's all positive. And I'm going to bring anything negative downstairs to turn it into a positive. Here I'm going to have a to the negative 4, b to the negative 6. Remember, I'm just multiplying those exponents. And the other side, I have a to the negative 15, b to the negative 12. And I'm going to keep anything positive, which is basically really 1. If you think about it, everything else is going to be down here. So I'm going to end up with a 19th and b to the 18th. Or number 10, I am going to end up with 1 over 32, and then I have r to the negative 20. So remember, 2 to the 5th power, if you think about it, 2 to the 5th power equals 32. So I'm trying to do the reciprocal of 32 is 1 over 32. And finally, I'm going to end up with bringing that negative exponent down here. Okay. So number 11. So if again, remember, you could think about this as negative 11 to the negative 2nd power, and x to the negative 6, and y to the negative 2. And if I think about 11 squared, it's 121. So I'm going to end up with the reciprocal, which is 1 over 21. x to the negative 6, y to the negative 2. And I'm going to rewrite that as I'm going to keep that fraction and bring everything else down. So that's a big denominator there. Number 12, going to end up with x to the negative 6, y to the negative 12, and I'm adding, so be careful there, because that's a new concept. You might be in the habit of multiplying these, but now just watch for that. So I put that in the box to remind myself. And then I have x to the negative 6 and y to the negative 12. And remember, I'm adding, so do I have like terms here? I do. Remember, I need like terms when I am adding or subtracting monomials together. I end up with, in essence, 2 of these whole things, right? 2 of those. But then I remember I want all of these as positive exponents. So I'm going to bring everything else down. Number 13. Now I am adding a new operation that I am dividing. So if you think about 1 minus 2, I'm going to end up with m to the negative 1. Remember, anything a variable to the negative 1 is really just its reciprocal. Oh, now I'm getting a little tricky. So I have factor, let's see, 24 divided by 4 is 6. And I could think about 4 divided by 4 is 1, right? So I'm going to end up with negative 1 over 6, and then x 2 minus 5 is negative 3. And I'm going to put all of that over 6x to the 3rd. And box that. I'm going to box that. Okay, so for number 15, oh good, these are friendly too. So I can divide both sides by 7. So 21 divided by 7 is 3. 7 divided by 7 is 1. So I'm going to end up with negative 3. 5 minus 4 is 1. And then 2 minus 5 is negative 3rd. So over here, I'm going to hold on to that. I need that positive variable, and I have that negative 3 up here. Remember that negative 3, just because it's negative, it still stays on top. But I am going to bring the x to the 3rd down. 16. I can find a common factor here. It looks like I can divide both sides by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. So I'm going to end up with 3/5. And I'm going to end up with an a, because 2 minus 1a. 1 minus 3 is negative 2. 4 minus 5 is negative 1. So now I'm going to rewrite that. 3, and I have a positive variable up here. I'm going to end up with 5 b squared c to the 1st, which is really just c. You don't really need that first. It sometimes comes in handy. Number 17. Oh, good. It's pretty neat, too. So 9 divided by 3 is 3. 3 divided by 3 is 1. And let's see, I'm going to end up with 3. X to the negative 6, because I'm subtracting 10 from 4. I'm subtracting the y, 7, from 3. So that's going to be y to the negative 4. That's going to equal, so that's the value that I want on top. And I'm going to bring everything else down. Will I get through all of it before the time that class starts? We'll see. 14 and 7, that's neat. So 14 divided by 7 is 2. 7 divided by 7 is 1. So I know that's just a half. B, oh, and the A's neatly cancel each other out. Now I have b to the 6th. I can't read that. Oh, minus b to the 9th. So I'm going to end up with negative 3, or negative 3rd power. And then I have 1c left over. So let's rewrite that as positive. Okay, so I could write 1/2, and I could write c. And then I'm going to end up with my b to the 3rd power, because it's negative. Now, do I need my 1 there? I don't. But again, sometimes it's nice to put it in, but in correct form, it's going to be like that, because that's an invisible coefficient. Let's see, is this a neat one? Yeah. 9 fits into 36. So 36 divided by 9 is 4. 9 divided by 9 is 1. So I'm going to end up with negative a quarter. I'm going to end up with no x's because they cancel each other out. I have a 5 minus 4 for the y, so I'm going to end up with a nice positive y, and then 3 minus 5, which is going to yield me negative 2. And that is going to equal, well, it's all going to be negative, because if you think about, and I'm just going to rewrite this, but again, you're going to find out you don't really need to, but I'm going to end up with a y upstairs, and then I'm going to end up with a z squared downstairs. There's the bell. Now I can get rid of the 1 if I want to make it proper, but I like to write them for my own sake. Okay, we're almost done. Let's see if I can do it. This is a neat one. 15 divided by 3 is, well, 3 divided by 3 is 1. 15 divided by 3 is 5. So I end up with 5 on top, but it's negative. R to the 4th. Again, I'm just subtracting s to the negative 2 and t to the negative 3. And that is going to be, I'm going to hold on to my negative number on top. This is still a whole number if you think about it. That's my positive exponent, and I'm going to put it all under s squared t to the 3rd. And last but not least, I have this one. So I'm going to put a lot of these concepts together. So I'm squaring, right, these. So I can even rewrite this as, because I'm squaring the tops here, right? I can rewrite it like I'm multiplying those two together. So I'm going to rewrite the top line. 4 times 4 is 16. I have x to the 4th power, and then y to the 10th power. And then down here, wow, I'm going to end up with 2 to the 3rd, x to the 3rd, y to the 6th, if you think about it, times 3 squared, and then x to the 6th power. So if I rewrite this, ooh, this is going to be a long one, if you look at that for a minute. 2 to the 3rd power, we have 8. And then I have 6 plus 3 is 9, so I'm going to end up with 8. X to the 9th, I'm going to take care of these variables for just a minute, and then y to the 6th. But then I also have to take care of 3 squared, which is 9. Here, I'm going to draw a little line here. 9 times 8. So on the bottom, I'm going to have, man, this is getting small. I'm going to end up with 72. I'm going to rewrite this later in just a minute. On the top, I ended up with 16x squared y to the 10th power. And I'm going to hold on to these. Okay, so when I rewrite this final question, I have 16 over 72. I know that they're divisible by 8. So I'm going to divide 16 by 8, which is 2. I know this is getting messy. 72 divided by 8, which is 9. So the final answer for this one is going to be, I'm going to rewrite it right here. It's going to be 2y to the 4th power, 9x to the 5th power. And guess what? I'm going to box it, and I'm going to bring it down, or at least point there. So if you take a look at that and take a look at how I got that, right? We have our x's that I was subtracting and the y's that I was subtracting, and then I took care of my positive and negative exponents. Oh, 15 minutes later, bye.